We're at gotomath.com, working some calculus, go down to area, and we're going to be doing another one of these absolute values. So if you haven't seen 4.1 yet, you need to check that out really before you get to 4.2. This one here is a little bit trickier. So let's click on this one. It looks the same, but it's deceiving. Let's click on this a couple times and see what we got. See what happens here. Okay, doesn't look too bad. So we're going to be finding this area. Now remember, this area is below the x-axis, so we're going to end up getting a negative number, right? So we want to make sure it's positive. And then this area right here obviously is going to be positive. So we're going to be finding this area and then adding it to this area here to get the total area. Now remember, we're trying to find the area between the curve, which I'm calling this the curve here, and the x-axis, right? So this is kind of like the trapped regions right here. All right, so let's go ahead and write it down. Like I said, you need to see 4.1 if you hadn't already seen that one. Work that problem out before we really get to this one. All right. So we'll break this up because really this will be written as a piecewise defined function. Ow. Burned my arm on my lamp. You're going to break this up into two. We got to identify this line which goes with this line here, and then which one that goes with this line right here. Okay, so we got several problems here to work. Actually, I'm saying first we're going to find this area, and then we'll have to find looks like the area between 3, 4, 5, 6, 7. Between 3 and 7 we'll have to find this area, and of course with symmetry we can just multiply our answer, right? We always want to use symmetry as the advantage here, shorten our work. So as you can see here, we got a triangle that's symmetric, okay? And we can just find this area and then simply multiply by 2 and be done with it. And I think that's probably what we're going to do here. All right, so I always promote use symmetry to try to simplify things. Okay. So we're going from 0 to 11, and we got to negative absolute value of x minus 7, and then plus 4. Okay, we'll go ahead and just put everything in parentheses here, and the dx. And I guess I should probably kind of sketch out what's going on here. All right. But the first thing I'm going to do is go ahead and write f of x is equal to negative x minus 7 plus 4. But now we're going to write this as a piecewise defined function. So the first thing I'm going to do here is, actually I shouldn't write equals there, like this. Drop the absolute value signs and then distribute this negative across. We end up with negative x plus 7, right? And then we have plus 4, and of course this becomes negative x plus, wow, can't add 11, right? Okay, so this is the one that has the negative slope, going to be crossing at 11, so that's going to be this side of it. And then if I remember right, it's doing something like that. Okay, and we're going to be finding this area and this area here, right? And then we just multiply this area times 2 to get this area here, which definitely doesn't look symmetric. Let's do that and erase this line here, okay? Okay, well this is actually this line, and we said we're not even going to use that. We're just going to go ahead and use this guy right here. Okay, so then that means that we multiply the outside by negative. All right, multiply the outside by negative, and so that just causes us to drop the absolute value signs. Now remember, this domain is x is greater than 7. Okay, and then the other part, we just multiply through by negative on the end. That gets rid of that negative, and then we drop the absolute value bars. Plus 4. So we end up with x uh, minus 3. Is that right? Should be right. Okay, because when we plug 0 in for x, we should be getting negative 3 here. Set it equal to 0, we get 3. Okay. Alright. And of course, this is for x that's less than or equal to 7. Okay. Alright. And I should probably note, I mentioned piecewise defined function, and usually a piecewise defined function is written like this, and we'd say something like, what would we say? Actually, we would put, well, it doesn't matter, I guess, but we'd put plus 11 here for x is greater than 7, and usually this part goes, or this part would go last, but I ended up writing it first. So anyway, so this thing right here this is another way of writing it, alright, as you can see. But we're just going to be working with this line right here. That's all we're going to be doing. So we're going to be going from 0 to, what did I say, 3? From 0 to 3 here, defining this area. Alright, so we're going to be going from 0 to 3, and we're going to be obviously using this one, this part here of the piecewise function. So this is x minus 3 dx. Okay, so we end up with x squared over 2 minus 3x going from 0 to 3, because I always like working with 0 because everything cancels out. So you got 3 squared is 9 halves minus 9, and so we end up with 9 minus 18 is 9, negative 9, right? We get negative 9 halves, but now it is negative 9 halves, and let's not deny that. But remember, this is area right here, so if we're calculating area, this area must be a positive number, so we just multiply it by negative 1. Now, you can also remember, flip this. You can put the 3 down here and the 0 up here, and that'll cause that to be a positive 9 halves. So keep that in mind. So this area is 9 halves. Now, let's find that area. So this time we're going to be going from 3 is our lower limit from here to 7, right, of x minus 3 dx, and of course you get x squared over 2 minus 3x, same thing, except we're going from 3 to 7, and I'm going to go ahead and work that out right down here. So we have 7 squared is 49. We might as well try to do some calculations in our head. Minus 7 times 3 is 21, minus, start a parentheses right here, plug 3 in, 3 squared is 9, so we got 9 halves, 3 times 3 is 9. Alright, so we know what this is. We already did this. This is this right here, right? Negative 9 halves. Okay, but I'm going to go ahead and just plug it all in at one time there. So I'll let you try to figure that out. 49 over 2 minus 21. And then we got a minus, and a minus 9 halves is going to be a plus 9 halves, isn't it? That makes sense. Is that right? Yeah. 8. I'm getting a nice number like 8. That's nice. Wow. So this area is 8. So if this area is 8, then there ain't no need to doing the calculations for this guy right here, because we know that this is 8 also. So therefore now we have 9 halves plus 16. So 9 halves plus 16. I got 41 over 2. 41 over 2. Now remember, this is units squared here. Okay, units squared. 41 over 2. Of course, I always hold my breath when I click the answer button. And that's what script shows. Of course, I've checked it a million times. But anyway, 41 over 2 is the area. You need to come on over, practice those, and good luck.